Here's the recording started.
All right.
Okay, now that it's official.
Right.
Okay.
So tonight we're going to deal with cosmology, which is the study of the cosmos on very large scales. And in particular, we're going to go look at how different ideas of how our universe started up.
Right.
And of course, there's very hard to get evidence on this other than what Ron did. So I'm going to highlight what Ron did as well.
Right.
And I think that's important. But the main thing about this to keep it in mind is that it all starts with the telescopes and looking out in the heavens.
Right.
And you know, what happened was you started with Galileo, who had a very simple telescope, so that they kept getting improved. And it's really only at the end of the 19th century, early 20th century, that they start to be able to gather enough light in. That's the key thing, is to get enough light so that you can discriminate things out there. And in particular, there was a guy, Percival Lowell, who set up an observatory in Flagstaff, Arizona, right by the Grand Canyon. And so he had, telescopes there. He unfortunately turned his telescope toward Mars and said he saw channels or canali on Mars. And people did some more checking and they couldn't find any such thing. So they figured his telescope was a little dirty, or, there was something wrong with it. But he ended up then recruiting this guy out of Harvard, Vesto Slypher. What a name.
Yeah, really.
So in 1912, Vesto turned this telescope toward the heavens, and he started looking around at the different stars, and he was able to measure basically their velocity. So you have, with each of these stars, they have elements in them, and the elements are in this nuclear fireball, which is the star. So each of these elements generates its own discrete spectrum of light at different frequencies, and you put them all together, and that's unique to this star. But because the star is moving, the spectrum can get shifted, and it can get shifted toward the red part of the spectrum. The spectrum goes red, orange, yellow, green, blue, indigo, violet. So the red side means that things get pulled away. They get, if you will, longer wavelengths, or if the wavelength gets longer, the frequency, also is going to get longer. Okay. And the other side to it is being blue shifted. So if it's coming towards you, then the wavelengths are all getting crunched up, so that they're getting shorter. Okay.
Right.
So you have to go look at how these things shift. And he discovered in 1912, when he was looking around, that it seemed like all of the stars that he was looking at were moving away from one another. They were all red shifted in their spectrum. And so then we went through World War I, and a new telescope came online there in Los Angeles, the Palomar telescope, and that was even bigger and better. So this guy, Edwin Hubble, looked at that, and he discovered not only what Slypher had come up with in 1912, because Slypher had, his telescope was right on the edge being able to show this, but Hubble showed it for all kinds of stars, that everything was moving away from us. And so this was, because Hubble had done this, it's called the Hubble redshift, and it shows how quickly things are moving away. So this impacted what Einstein had just done, because he had just developed his theory of general relativity, and he had in it a fudge factor. and he initially had the fudge factor set at 0, but because Hubble saw everything moving away from each other, Einstein's equations didn't match what was really going on. So he put the fudge factor in, and that got everything expanding. So the universe that in the models that Einstein came up with was an expanding universe. And that, of course, led to the obvious thing, which was, well, if it's expanding, then it must have started off in some place. And where it started off is probably all together, okay? So that leads us into, what did we know about the start of the universe? So let me go here. Oops, hold on. Let me get rid of this. We'll go here. Okay, and let's see, how do I do this? There's some.
We found out how to get the music so that you can hear it.
Yeah, but these don't have music. We can get some with some music at the end. I can do that, but I'm just looking to see.
And the voices, for that matter, so you can hear the sound. It's a setting in Zoom that we were missing. And
yeah,
we did a call with somebody, last Sunday, who knew this trick. And
yeah. So what we're going to deal with here, let's see. I think I opened the wrong one. Hold on a second. Yeah, hold on. I'm going to get out of this and go back. This one is an Acrobat file. I want to do the PowerPoint one so I can go into a slideshow mode. So let me do that. So that's here. Okay. And now I go to Zoom. And I go here. I think this will do it. Yep, here we go. So I can do slideshow mode here. So here we go. Slideshow from the beginning. So we're going to deal with first the creation story that most people pick up somewhere along the line, and it's from the Bible. We're dealing with the King James Version, and so we go to look in Genesis, the book of Genesis, see what's going on, and then we'll look at a second creation story that was due to Isaac Asimov, and then we'll argue why Isaac Asimov is right. So we'll see.
All right.
So in the beginning, God created the heavens and earth. The earth was without form and void, and darkness was over the face of the earth, and the Spirit of God was hovering over the face of the waters. And God said, "Let there be light," and there was light. And God saw that the light was good, and God separated the light from the darkness. God called the light day, the darkness he called night, and there was evening and there was morning of the first day. Pretty powerful stuff.
Oh, wow. Wish I could do something like that.
And so it goes. Now, what did Asimov do? Well, he wrote a story in 1956. It was called The Last Question. So this story, you'll see how it ties into Genesis at the end. The story centers around multivac. So in 1956, everybody thought that there'd be one gigantic computer eventually, and it would run the whole world. Okay.
Well, that may be the case.
Yeah, we don't know. But in fact, it might be the case today, and we don't even know it. So this computer was called multivac, and it was a self-adjusting, self-correcting computer, and it was fed data for decades, and it was assessing all kinds of data and answers. And finally, in 2061, the latest, greatest version of multivac came online, And the story actually has 6 scenes. So we'll deal with the first scene, but the others are just parallel to it. So the question that came up, they were celebrating the latest, greatest version of multivac cutting over. And they also realized that there was, that the universe was gradually cooling off. And this was called heat death. There'd be no heat left. There'd be nothing but darkness and cold and an abyss. And the question that was posed was, how can the net amount of entropy of the universe be massively decreased? So entropy is always increasing as we get colder and more random. Things get closer and closer to an absolute zero. So this deals with the workings of the second law of thermodynamics, which deals with uncertainty. And Multivac was asked this question by the guys who had just helped cut over the latest, greatest version, and responded after a while, insufficient data for meaningful answer. Insufficient data for meaningful answer. Okay. So we go forward into later periods of time, and there's as humanity expands in the universe, computers became more and more compact. So now we have microvac computers all over the place, which are actually more powerful and yet smaller than multivac. And these things show up in different epochs as humanity fills up the Milky Way galaxy, and then they fill up several more galaxies and on and on. And in each era, someone decides to ask the ultimate last question: how do you reverse the decrease of entropy? And so each time that one of these descendants was asked this question, it answered, there's as yet insufficient data for a meaningful answer. So no answers whatsoever.
The decrease of entropy?
Yeah, when you have entropy increasing, that increases disorder. So when you decrease entropy, that leads to greater order.
Right.
So that's what they were saying, was we want to decrease entropy. So in the very last scene of this story, there's now just a few people, one person left, and everybody else has been uploaded to this automatic computer, just called AC. Now, this computer is so advanced that it exists in hyperspace. And so that it's not even in our space. So everyone that's left, with just one exception, trillions upon trillions of people have been uploaded into this thing. The stars are slowly flickering out one by one. There's really nothing left. It's just cold, dark. Pretty soon there's no notion of time, because there's no activity. There's no energy left to go do anything. And so the last person asked the last question one final time and gets the same answer, and then uploads into the AC and is gone. Now, there's no one left. The universe is empty. It's just a dark, quiet nothingness. And the AC, which is often hyperspace, is unable to answer the question, but it's still pondering the question. And after a period, again, there's no notion of time, because there's nothing in the universe. There's nothing left. So who knows how long this took? But the AC,
this is what we could call the dark nightmare side of unity.
Whatever. So the AC realizes that it actually began looking at all the data, all kinds of combinations, rearrangements, and everything. And at the end, it discovers the answer, that in fact, it is possible to reverse entropy. And the only problem is there's no one left. All the people are now part of AC. They've all uploaded there, and the universe is completely dead. So AC says, well, let's do a demonstration then, okay? Just to answer the question, we'll have filled our purpose. So AC says, let there be light, and there was light. So there you have Asimov's view on it. Now, what we'll argue here is that Asimov was closer to what probably really has been happening than Genesis was. and we'll see why as we get into this. So let's go back to what we've been able to do since 1920s, 100 years now, with bigger and better telescopes. Okay, in the 1960s, with these telescopes, it was actually discovered that there's a black hole, and it's in the middle of the Milky Way galaxy. And in fact, every galaxy that they could find so far appears to have a black hole in it. And the black hole, though, has the mass of millions or tens of millions of stars. It's inconceivable, the gravitational attraction of this black hole that's there. So that's the first thing that we keep in mind. And then we have this other thing that came up, which is dark matter. And here, what happened was in the 1930s, one of the people at Caltech, again in Pasadena, used the telescope and looked at these galaxies that they could now see. They couldn't really see the galaxies of that are out there until this point in time, and they saw that a lot of them were spirals, and that they appeared to be spinning. So they could do some estimates of how quickly they were spinning, and then they could do some estimates of, if there's 100 million stars in this galaxy, and they have, each of them has an average mass of the size of our sun, for example, and it spins, then what happens? And it became very clear that if that was the case, that the galaxies would just fly apart. There wasn't enough matter in the galaxies that was there to hold them together. The spinning the gravitational attraction of the stars in the galaxy and the speed at which they were spinning, it meant that there had to be other matter that couldn't be seen. Since it couldn't be seen, it was simply called dark matter. And the
It's
dark
like junk code in DNA.
Right. So the dark matter, in fact, is 5 times as prevalent, was what they needed to come up with in each of these galaxies to be able to hold them together. And the thing that goes with this is we had matter, now we have dark matter. And then in the 1970s, they finally had done enough, of looking at different how galaxies were spinning and so forth, that it was really not in doubt that there was something like dark matter, but they had something else as well, which was what they simply called dark energy. Dark energy, remember, the stars are moving away from one another. And if the stars are moving away from one another, then there's an energy which is actually pushing or expanding space itself. So it's not really you'd have to ask yourself, how in the world would you measure this dark energy? So the only thing you can do is look at how quickly things are expanding. And there's been a lot of work done over the last 100 years. Guys got the Nobel Prize in this century for refining these measurements and showing that, if anything, the dark energy is accelerating the expansion that they measured up to this point. So we've now got 100 years worth of astronomical observations that we didn't have, and it shows that matter is a small fraction, perhaps 5% of the universe. Dark matter is probably 27%, of the universe. That gets us up to 32%, and therefore dark energy is 68% of the universe. So
Wow.
dark energy is twice, matter and energy are equivalent to one another if you believe E equals mc squared. So dark matter is half the mass energy of dark energy, and matter that the physicists have been dealing with for 500 years now is like a very small part of the story. Now, what Ron Cowan did was he
I
actually
just want to
go ahead.
to clarify, I just want to
Sure.
back up a little bit. So there's the thinking is that there's a force that is actually propelling everything apart. Is that
Yeah,
right?
yeah. It's called dark energy.
So there's the attraction force.
The attraction is gravitation.
Okay. But that's actually weaker than whatever the force is that's
Yes.
propelling everything apart.
Right.
But what do they normally mean when they talk about the weak force?
The weak force is totally separate from this. The weak force is, if I look at it at the nucleus of an atom, that hydrogen just has, in the simplest example, just a proton, but hydrogen has isotopes. So deuterium has 1 neutron and 1 proton, and tritium has 2 neutrons and 1 proton. What happens over time with the weak force is one of those neutrons decays into a proton and an electron and a neutrino. That's the weak force forcing that decay. So all of a sudden, the amount of, for example, deuterium that you would have starts to drop because I lost a proton there. So now I have 2 protons and one and nothing else, and so they push apart from and I end up with just 2 hydrogen atoms.
So,
okay?
well, do they think that's connected to what's pushing things
No.
apart? It's
No.
just another phenomenon of
Right.
but it's because they're too much alike, they're repelling each other. Like
it's a force that only works on the nuclear level. Okay, and
That's
the
right.
things that we're talking about here are working on a scale of trillions of light years, incredible scales, and it appears that gravitation works over those scales, those incredible distances, and that's what leads to this. Now, Ron,
but they could never really connect the microscopic and the macroscopic.
No, they haven't. That has not been done yet.
Okay.
Right. Ron made some great observations. So when he looked at the chakras, each of us has 7 major chakras that they appear to be made of dark matter. Now, the dark matter appears to be nothing but what are called subquarks, but the subquarks have no charge to them. And in fact, dark matter has no electron to it. So dark matter, the only thing that acts on dark matter is gravity, because gravity has no charge related to it. All the other forces, electromagnetic forces, the strong force that holds the protons together in the nucleus of the atom, the weak force that makes the neutrons decay, those are all nuclear scale forces. And the thing that Ron observed was that for whatever reason, we seem to have these dark matter chakras in us, and that they appear to live forever. There's no reason to believe they would decay or do anything. And I think that's a key observation toward going forward and trying to make sense out of all this stuff. So that's where we're at today. So what's going to happen to us going forward in time is eventually all of these stars that we see everywhere will all burn out, and the black holes that are in these galaxies will continue to grow and consume everything. And then the black holes themselves, even the term black hole means that nothing escapes from it. But they discovered that that was a mistake, and that in fact information leaks out of the black holes. And so the black holes are all going to evaporate. So there's going to be no stars, no planets, no black holes, no nothing. Okay. So the only thing that's left is the notion of having souls. But again, Ron observed that the souls appear to be in this separate subspace where the dark matter is. It's where the chakras are, and that there'll be no notion of time, because if there's nothing going on whatsoever, what are you measuring? It's just a void. There's nothing there. It's all at absolute zero temperature. No electrons, no anything. Okay, so that's where we're going. And what happens in this, what the mathematicians came up with, was that actually when you go to this state of having nothing, that you actually can flip things back around. And so the compartments of space that are out there that are containing this dark matter, those themselves are going to collapse. Okay. And as they collapse, they're going to, space itself is going to shrink back in on itself. So what went out everywhere and is simply a void is going to, as space collapses, come back in, and everything is going to get pushed back together into something very small. And in the other literature, this is called the primordial egg. Do you want to say anything about the primordial egg? It's going to be, basically an egg that's going to create the next cycle of the universe. So the idea here is that the thing will go back to this egg and then bounce.
Well, it's infinite potential. That's what I would say. I'm hearing this all through a Kabbalistic lens as you're speaking, and this is. I do believe it's in the Hindu scriptures as well as the Kabbalistic teachings that it's like breathing. It's kind of continually expanding and contracting.
Right. So we happen to be in one particular epoch where what we call the universe is expanding, but it will actually go through a cycle. It'll collapse on itself and then bounce back, and there'll be another universe there. And this will happen ad infinitum, apparently.
The thinking I've been exposed to is that they think it may be happening all the time. But
it has to be happening all the time. But it isn't obvious.
You don't perceive it.
Yeah, until you get down to where the compartments of space themselves will collapse. Okay. So when they collapse, then whatever's outside of space, whatever's outside of the universe, who knows what that is? It's not space, but space itself will collapse down, and we'll get this very small primordial egg, which will then bounce and come back and create a new spin of the universe. And when that happens, just after the bounce occurs, that's where you have this, what's called Higgs boson shows up. And there's nothing in this universe here except dark matter. So there's no electrons, there's no protons, there's nothing but these dark matter subquarks that are in these space compartments. That's it. And they don't have really a lot of mass. So this Higgs boson shows up and gives matter mass, and it gives extra boost for the dark matter mass. and then the universe itself comes into existence.
What I've understood you to say about that is that it's like a spacer. It becomes the gauge, the divine gauge that everything is measured from.
Right, right.
And without that, there's no relativity.
There's nothing. There's
nothing to compare anything
no
to.
no.
It's just what I call this blob of oneness,
Right.
which seems like a really good description of hell to me. But,
Yeah.
but then the spacer makes everything possible.
Right. So another thing that happens when everything collapses on itself and then starts to bounce and expand, you've got something here. You think of it as like some water. Okay, so everything is now this primordial egg. It's the entire universe is here as water. So as the space compartments now expand, as they start to, they've collapsed now, so they start to expand. It's like having a phase change, so that the water evaporates, and you end up with the universe exploding in size by, it appears to be at least 30 orders of magnitude after when this bounce occurs. Now that's important because if you look at the sky, one of the problems you have is it looks like the stars are pretty much uniform in the sky wherever you look. So if things were really very lumpy, okay, if there was really an explosion that took place here, that it was something that took some period of time, you can see that a lot of explosions have things where something is exploding here, but right next to it isn't exploding, and over here it's not exploding nearly as much. So the net effect would be that when you looked at the stars that are in the sky, they'd be clumped together. There'd be areas where there's no stars, and there'd be other areas where there's lots of stars, and that isn't what we see. We see everything spread out everywhere. So the space itself has to inflate, has to expand, and it does this right at the bounce in going through like 30 orders of magnitude, and then it slows down. And the thing that happens here, this is what Ron observed, okay, is we end up having the space compartment, but it's actually existing in this 26-dimensional space. There's 24 spatial dimensions and 2 time dimensions, one here and one there. And all of these things just blow up on you is the only thing I could say. So it's an amazing thing, and this appears to be much more why Asimov is correct. The other thing that Ron observed, this is probably just as important, is that the space compartments have these little blobs of information that are scanning all the time. And they're in space compartments for matter and space compartments for dark matter. They're everywhere, and they have in them a set of rules, a set of algorithms for governing how they'll expand and how they'll behave, which are the laws of physics. And they're governed by the principles of mathematics. So this is an amazing situation that controls everything, and a lot. And this is really what Ron's contribution was to key on all this stuff. So now let's take a look at the second thing here. Hold on a second. Not this one. This one. This is what I want. So what we have here is, here's a picture of this primordial egg. here, but it has this serpent wrapped around it. You want to explain why there's a serpent?
Well, it's otherwise known as the Orphic egg. Well, it's an image. It's hard to explain. It's really kind of like what you were just talking about. It's a metaphorical way of putting it that comes out of the Western esoteric tradition, which probably comes out of the Middle East. And it has to do with the serpent in the Garden of Eden, which has to do with Kundalini. That's what they were talking about. That
It was there at the get-go.
right. The
Right.
perfect word is primordial. It's energy, and it's the origin of things.
Right. And now down here in the other corner, though, I put a picture. So what happens with these telescopes is they take pictures, but they can do that at different wavelengths, at different frequencies. So since they do it at different frequencies, they use colors to show the change. So red is the lowest frequency, blue is the highest frequency. So you can see this is a region of long wavelengths going to shorter wavelengths. And there's no way to beat these astronomers. These pictures, I'm always in awe of how great these pictures are that they come up with. I mean, who would ever think of doing a picture like this? This is amazing. So what we have here is, we'll just call it an autodidactic universe. And the universe teaches itself. So it has a bunch of laws that are in these blocks of information that are everywhere. And the laws that are there, why are these the laws? Where did these things come from? So there's a whole bunch of things that the physicists run through, and they're trying to sort out all of these different things here, and they end up with two problems. One is that on the scale of cosmology, these really long distances, they can't come up with any theory that will explain what happens on very short distances. And that is called the quantum theory, or the discrete theory. They believe that everything is ultimately quantized. So space by itself is a foam, it's quantized, but it's not clear what happens when you extend this out to millions of light years, billions of light years, and so forth. So anytime the physicists have tried to deal with this sort of stuff, they failed. There's been no real progress. They've hit a stone wall, and it's been for the last 50 years, since the middle 1970s.
It seems like it should be analogous,
Right.
Just
right.
intuitively, it seems that way. But
So what it appears to be going on is, either there's no reason why the physical laws are what they are, why the scales on which these forces work is what they are, and it's just it is what it is, or there is an explanation based on reason, and the physicists are going to go and try and find it. And so we have all of these magic constants floating around. How strong? We have a gravitational constant. We have all kinds of constants related to wavelengths inside the atom. So any sort of explanation would suggest that these values arrive through some algorithm, so some process, but no one knows what that is. So the bet is that there is an explanation here, and we'll go find it. So here's a nice little book by this guy at Princeton, Peebles, and he devoted his entire career to this topic called cosmology. So here we have, for example, This is a quasar. This is a star that has been absolutely hammered, and it's shooting out jets up and down of matter at incredible velocities. And the energy for doing this is totally ridiculous. Here's a different picture down here of a nebula that was observed. You know, I mean, you just look at this and you go, what in the world makes this thing look this way? What makes this thing up here look this way? You know, so here, this guy has devoted his entire life to doing this. How did everything begin? Where is it going? Where will it end? Okay, and we're just in the middle of doing this. It's clear that we have incomplete answers, and that everything we've seen so far, we're going to have to take with a grain of salt. We could have to change things. And one of the examples of where change is going to be required is the physicists all believe, well, if all of this matter started off in one place in this Orphic egg, then it would be incredibly compact. And just by the vibrations of this matter, it would have temperatures that would be unbelievable. They'd be far, far beyond any star that we know of. And as things expanded after a period of time, which the current estimates right now are 300,000 years from when the bounce occurred, 300,000 years, things would have finally cooled off enough so that you had a situation where the electrons and the protons and neutrons were just mixed together with one another. They were so hot, they were just in a big stew. As they cooled off enough after 300,000 years, then the electrons started to get attracted to the protons and neutrons, and you started to end up with elements occurring, physical elements. And there appeared to be a void and a light, and the light was the physical elements that started to cluster together to form what we would call stars. So, you know, this is why it's going back to Genesis, and you see the notion of night and day is they're grasping for something like that. The problem with this is that Ron went back and observed what's going on here, and he didn't see anything like this. He just saw a bounce occurring, and he didn't see any notion of a nuclear fireball. I asked him about this repeatedly in different ways. So it was just a bounce. And after it inflated, after it expanded a whole bunch, then we started to have things like stars created, but there wasn't any, you know,
Do you
nuclear.
have that graphic in here of
The-
the bounce?
There's
Of the
a
repeated bounce?
there is a bunch of those which we can come back to.
Because it's on the.
We
resource.
saw it. Yeah, we saw it in several of these YouTube videos. I didn't want to take the chance of cranking up YouTube in the middle of doing this because we got enough stuff to cover.
No, I'm saying we have one in our syllabus, a good image of it on our resources page. And I wanted to show Richard's painting if we could.
Okay, hold on a second. Let's see.
Because I think a picture is worth at least 300,000 words. So that's a beautiful depiction that the artist that we had come visit with us did, representing the Kabbalistic creation of the universe.
Here, we'll just go here. So here's our website. And here's the Kabbalistic version of this tree of life.
Well, this is his version of the Kabbalistic tree of life.
Abstraction.
Right. But then.
You want to go to the syllabus? Go to modules. Go to modules and go to syllabus.
So here's his painting. It's page 1. And then let's do this. There's a poem about what we're talking about. And then here's this image.
Right. So this is an abstraction showing that the universe goes through, this is a contraction leading to a bounce, expansion, then it comes back together, another bounce, and so forth. So again and again and again. And there's no beginning and there's no end to these cycles that are occurring there. If you look on the web, you'll discover that the Indians say that we've gone through 29 cycles so far. I have no idea where they came up with 29. But anyway, the web is amazing. You can find everything on it. So let's go back to, let's see, where was it here? Yeah. Oops. Hold on, I did one. We're still in slideshow mode. Let me escape. In Zoom. Here we are. We're in slideshow, so we'll go here. Here we go. Okay. So one of the things that shows up here is we have a bunch of magic numbers that came out of astronomy. This is just one example of how little is known. So there was a individual called Titius who did all the work. The problem is that this other guy, Bode, took credit for it. So that's why it's called Bode's law, but it actually is Titius Bode law. And he did this in 1766. And the question was, he looked at the orbit of Mercury. And so here we have Mercury. Then we have the orbit for Venus, for Earth, for Mars, and so forth. And he discovered there was a formula that relates them. It was that the actual radius of their orbit was something like 0.4 plus 0.3 times 2 to the mth power. This is an exponent here. So m is minus infinity. So in this case, for Mercury, it's 0.4. When we go to Venus, m is 0. So we get 2 to the 0 power, which is 1. So we get 0.4 plus 0.3 is 0.7. We go to m equals 1. We get 0.4 plus 2 times 0.3, which is 0.6. So we get a equals 1. So everything is normalized to the orbit of the Earth being 1 unit. So Mercury is 4/10, Venus is 7/10, Mars here with m equals 2 is 4 times 0.3, or 1.2 plus 1.4 is 1.6. So Mars is 1.6, with the Earth being 1 for its radius, and so forth. So all of these planets seem to follow this law, which is really bizarre. Like, why would you expect to see that sort of order with the planets running around? Okay,
I would expect it to be the Fibonacci sequence, but that's me.
I understand. This is
it's similar
right
to Fibonacci.
It's just an example of how order was discovered, and people started to realize maybe there's a deeper order underneath everything that's making this happen. So people looked at things related to the rotation of the Earth's inclination to the ecliptic plane, which is the plane that all the planets seem to be in, pretty much. How the Earth precesses over
the ecliptic
25,
plane, that means the apparent path of the sun and the moon,
and the Earth of the Earth. No, it refers to the plane of all the planets running around the sun. Okay.
But from my point of view, they appear to be going around the Earth along our ecliptic, along the middle
Right,
of
right.
our planet. That's the ecliptic plane, which just happens to line up with the orbits of most of the planets. Uranus is really different.
Right. So the Earth's inclination is roughly, I think, 23.5 degrees. So it's significantly tilted with respect to, like 0 degrees being perpendicular to the ecliptic plane, where we're inclined at it significantly. And then we rotate or we precess around this axis. So why in the world does that occur? And then we have all kinds of other things related to stars and constellations and the zodiac, with the 12 major signs of the zodiac, and so forth. And then beyond the planets, we have the things that appear to be leftover junk or asteroids or rocks or whatever that form a cloud called the Oort cloud. And then there's a Kuiper belt that has all kinds of other junk in it. And this is way beyond, this is way beyond where Pluto is, for example. So there's all kinds of things the astronomers have discovered. And yet, when we go back and look at this, we see that this cosmic egg, or that was, I'll move this down. Put it down here. That this cosmic egg, okay, is some sort of motif that's found in many different cultures. It isn't just something unique to Indian culture, for example, or China, or Western Europe, or South America, or Africa. But all of these different cultures seem to believe that there's some sort of hatching that occurs of an egg, and this leads to the creation of the universe. And in part, this is the notion of yin and yang that we saw in I Ching, okay, and in the way of the Tao, that there's always a balance between these things. So two complementary principles.
And we see it in computer technology.
Yeah.
Of the on and off.
Yep. So there's a big book that Madame Blavatsky wrote. We saw her when we were dealing with the Theosophical Society and the people that were there. And she has a whole section on this Orphic egg and what happened and so forth. So, and this is actually a direct link to it. If you click on this, you'll go see what she was talking about. So this we find in all these different cultures, and yet this isn't really what we find. What does this have to do with what Western science has come up with, which is this area called cosmology? Well, we talked already about how there was this guy, Slypher, in 1912, and Edwin Hubble, 1924. They started seeing everything move away from one another, which suggested they were all at a common point. And then the question came up, well, what happened like before that? And the thing that we saw happening here that appears to be what Ron observed also was, they called it the Big Bang because it was a catchy thing that the newspaper people could run with. But in fact, if everything is compressed, then it's not big. And if it bounced, then there's no bang. So there's no big and there's no bang, neither one. But the universe may simply go on again and again through these cycles. And there's a Nobel Prize winner, Roger Penrose, who wrote a whole paper on this and why this was more natural than just saying there was a bang that occurred. Today, if you go poll these cosmologists, you'll see that they thought everything happened 13.8 billion years ago, when just after this bounce occurring, or they view it as a bang, a very short period of time, perhaps a billionth of a second. There were all of these particles that came into existence. And if we waited over 300,000 years, then things would cool down enough so that we'd start to have atoms, and we'd start to have areas of light and areas of dark here, whereas up to this point in time, it was just a big gigantic soup of everything. And then as the matter clumped together and was forming these atoms of different sorts, different elements, then stars were formed and galaxies appeared and so forth. There was a totally separate theory due to Fred Hoyle, who was a very smart British astronomer, and he had advocated that matter was being generated all the time. He called it the steady state theory of the universe, and that as things expanded, matter was simply created out of nothingness, if you will. And his theory got just buried by all of this other stuff that happened here. And he got tired of trying to defend his theory. And he said, well, this other thing is just a big bang. And that was where the term came from. He was trying to disparage the Big Bang, and it backfired on him. And that's why people, they liked it. They said, what a great name. It's just like the same thing happened when Reagan announced the Strategic Defense Initiative.
Star Wars.
They called it Star Wars, thinking that they would make fun of Strategic Defense Initiative, and everybody loved it. They said, great, we're gonna have all the weapons to go take out everything. Star Wars, here we come. Not good. So we just look at what changed over the last 100 years. So in the year 1900, we simply knew that there was our galaxy, our Milky Way galaxy, and outside of it, there was some smudges that they could see on the telescope, so they couldn't figure out what they were. And then they started to realize that these smudges were other galaxies. And in fact, I've seen numbers of 200 trillion galaxies out there in space. No, that's a tip off that no one really knows how many galaxies there are.
And people really think that we're like the only quote unquote intelligent life.
Right, right. And this has been around for billions of years, okay? And then just to further confuse things.
And it's got to be like us, based on oxygen and carbon.
Right. The studies that have been discovered, there was a totally separate set of observations in the early 1990s. This guy in Geneva, Switzerland, was looking at a star through his telescope, and he saw the star jiggling. And he said, it looks like it isn't due to my telescope jiggling. It looks like the star itself is jiggling. And in fact, it looks like there might be something rotating around the star that is so massive that the star is rotating around a common center of mass. And the star is jiggling back and forth. So he went out and he showed these observations to other people. And of course, they said, you're out of your mind, you're stark raving mad. And of course, he was entirely correct. And there was a gigantic planet there next to the star that was orbiting it that influenced it, and it jiggled it back and forth. Then people discovered in the middle 1990s, some of these planets are so big that when they would actually go across the front of the star and obscure a part of the star. So all of a sudden the light in the star would drop dramatically, and then the planet would go all the way across in orbit and clear the star, and then the light would come back up. So they had a totally separate way of seeing these other planets. So if you go onto the web, you'll see there's over 5,000 what are called exoplanets, planets around other stars that are known today, and the number is just climbing through the roof. To make it further confusing, the Hubble telescope that's in orbit around the Earth has confirmed all these things and estimates that something like 40% of all stars have planets. Well, 40%, the Milky Way is estimated to have like, I think 100 million stars is one number I recall. And so 40% of that is 40 million stars having planets. And if they've been around for billions of years, it's highly likely that there's life on some of these planets that is probably far more advanced than life on this planet. And they could very well have come and visited here. Who am I to say? Who knows what happened? So all of this is just turning into a big can of worms, and they're realizing that their picture is very incomplete. One of the things that was interesting about what Einstein did in 1917 was he saw all these observations from Hubble and these other people, and so he included those in his equations of general relativity. And a priest, approached Einstein and said, well, if you follow this, then the universe is expanding, but also that means that the universe started off at a small point, a small region of space. And so that for the last 100 years has really preoccupied everybody. Hubble simply did the observations here, not to disparage them, that showed that everything was really expanding, and there was a lot of work that was done. But there's all kinds of problems now that have been discovered. So to start with, it appears that the radiation that's been observed is 13.8 billion years old or less. So that's when this bounce occurred, okay? Unfortunately, they've now discovered stars that are older than 13.8 billion. There's some stars that are 14.7 billion years old. Well, then how could that possibly be? This is not a minor problem, okay? That you have stars that are older than the universe, okay? And then there's all kinds of games that people have come up with to try and fix this, but to put it mildly, they haven't been able to do it. Plus, again, what Ron Cowan, was that there wasn't any fireball, which is what everything was based on. Was they're detecting the residual microwave radiation from this original fireball. And maybe there was a fireball, but it might not have been due to any bounce in the universe. It might have been due to something else. For example, I mentioned in passing that our universe could contract to an egg. Well, there's a lot of indications that there could be a lot of other universes out there. So there's something that's separating these universes, which couldn't be space, because space is what we've been talking about in our universe. And so this is outside of our universe. There's another universe, there's bunches of other universes, but if our universe is expanding, all these other universes are expanding. And so they're going to run into one another. And eventually, at some point in time, they're all going to merge and then go back to this cosmic egg again, okay? So one thing that happened here, this suggested that there was some background cosmic background radiation. That was what they were all looking for. And there were two people at Bell Laboratories, Arnold Penzias, who just passed on, and Robert Wilson, and they carried out measurements with a radio telescope, but they couldn't get rid of the background noise in the telescope, and they went over to Princeton to talk to this guy, Robert Dicke, who was on the physics faculty there, and Dicke had come up with this notion of there being a bang to start everything off. So they published these papers back to back. The Penzias and Wilson paper said, we carried out these measurements and it looks like there's this background energy, and there'll be a second paper, which is what Dicke wrote with his students, and it'll have a theoretical explanation for it. So Penzias and Wilson didn't want to go out on a limb of saying we endorse what Dicke said. They just said, we did these measurements and that's what happens with the universe. And so Dickey suggested, by going with general relativity, that there was this explosion or bang, and the real thing that happens is when you finally cool off enough after 379,000 years, 380,000 years, the temperature finally drops, if you believe there's a fireball there, to 3,000 degrees Kelvin, which is still, toasty warm. And that allows for electrons to combine with protons, and you end up with the universe becoming transparent to electromagnetic radiation. And so we have day and we have night, just like in Genesis. But the thing that the physicists went crazy over was this background radiation might not be uniform in all directions. There's probably some small fluctuations. So they put a satellite in orbit in 1992 that measured these things, and it showed that there were little speckles here on these things. That was fine. So it was smoothed out a lot, but it wasn't entirely uniform. It would have been surprising if everything had been completely smooth everywhere. So there were some lumps, but they're very, very small lumps, very small. And that's what happened here in 1979. Alan Guth, who's a classmate of mine, looked on this as really a phase transition, where the space itself changed from something like a liquid to something like a gas. And this resulted in space-time itself expanding, inflating 30 orders of magnitude. The one problem he had with what he did was that he couldn't see how to stop it. Okay, why wouldn't it keep expanding forever? And so some other people picked up on that, and then they started to pick up on other things. So this became because it matches what the Bible says, I think more than anything else, people loved it, and they carried out measurements that would confirm this bias a priori, okay? But Ron Cowan didn't have any such bias. He simply observed what was going on, and he couldn't find any evidence for this nuclear fireball that was there. And so it'll remain to be seen what is actually being measured by this background radiation. There's clearly something going on, but the interpretation of it remains to be seen. So what are some problems with this bang, with this universe that we've got here? Well, the first thing is that there are things called monopoles, okay? But they only have one pole. You have dipoles, they have two poles. You have tripoles, they have three poles. So there should be a lot of monopoles, okay? And there should be a lot of magnetic monopoles. So things that just have a North Pole with no South Pole, or just have a South Pole but no North Pole. And they should be around until today. And after going crazy looking for this, no one's found any monopoles whatsoever, okay? This suggests that the universe never was that hot, okay? So we could have had a bounce, but it's not. It might not have created a nuclear fireball like was suggested. The second problem here is that early on, you've just got these electrons, protons, and neutrons. So the simplest elements they can form are hydrogen that has one electron and one proton in its nucleus, helium that has two protons, two neutrons, and two electrons. And then the next element up is lithium that has three protons and two neutrons and five electrons. So that's what you would expect, is these are the easiest ones to form, and then the other ones that would happen after that are going to be much, much rarer. In fact, what they discovered was that there's way too much of these heavier elements here. Okay, that instead of just having these very light elements, there's lots of heavier elements, and that totally contradicts, what's going on. And furthermore, some of these stars, they fall into a category called population 3 stars. So they would only have these light elements in them. And we won't go into what population 1 and 2 are, but population 3 stars, just having hydrogen, helium, and lithium, no one's found any. So this makes you wonder, this is not a minor problem either with what's going on. Then they keep looking for evidence of inflation, and they can't find it, okay? Although it appears that's how you could get things to happen. And this is what Ron Cowan observed. Ron watched the space compartments expand or inflate. And so to me, that's, much more compelling than saying that there wasn't any, what you say evidence. Ron is looking at space itself and seeing these scrunched up space compartments expand. But the people that are doing this stuff, they don't have the capabilities that Ron did. And so they have no way to go show, was there really inflation occurring? And then all kinds of other things. There's in an area that in this cosmic microwave background radiation, there's some area that's a little hotter than others, and there's a cold spot and so forth. And there's problems with these too, okay, that you have to go deal with. I'm just going to skip through this. So there's problems out the wazoo with doing these things, all of which suggests that the current theory of having a bang isn't going to work, and we're going to need to go to something else. And the bounce appears to be the most plausible way to go approach it. And there's a lot of work here. There's a couple of articles, one in 2018, one in 2020, showing that that there's a bounce that occurred, and people are going crazy on this stuff right now. So this is very current work. Another thing that comes out of this is that, as I touched on this, is that there could be multiple universes out there. In fact, who knows how many universes there really are? So you can end up with all of these different universes. So it's simply called a multiverse because it has a universe made up of many universes, and they're all expanding. Okay, that's what's wild about this. So they're expanding, they're going to go run into one another. And what in the world does that mean? What happens when one universe hits another universe? Does all hell break loose? Who knows? And so we come back to what Ron did, which I think is the simplest approach, and we'll see what happens. But he came back with a 26-dimensional universe where the universe is made up of compartments of space. So it's effectively a foam, but the foam is in 26 dimensions, and it's all covered with these information blocks. And then he had matter. So one type of matter are these electrons or protons or neutrons and so forth. And then there's a similar dark matter analog to these here that have no electron. And the ones for matter have 10 strings per each subquark, whereas the ones for dark matter have 5 strings per subquark. And so it goes. Then there we have bosons like the photon that we use in electromagnetic field theory, or the Higgs boson. They live in all 26 dimensions. So the fermions are in one 10-dimensional subspace. Dark matter fermions are in another, and the bosons are bouncing around everywhere, all through this quantum foam. I'll skip over this. One of the things that makes this bounce compelling is that it could be the electrons, in fact, evaporate, so that everything that's left in what we call matter, once you lose the electrons, the only thing that's left are these subquarks. And so all matter turns into dark matter. And if that's the case, then when the bounce occurs, then the electrons have to get recreated. They're gone, and when they get recreated, that means the Higgs boson has done its thing here to create this. The thing that Ron observed, though, was that the dark matter appeared to be linked to these chakras, or potentially to souls that themselves seem to live forever. So all of this we have to see. We're just in the early stages of messing around with this.
Then that brings us back to my question for Bruce, which is who or what is reincarnated?
Right. Who is being incarnated? That's a good question.
Much less reincarnated. And
well, ask Bruce. What, you know, the question is, you have this soul or spirit entity, whatever it is, and it incarnates. It links up with some biological material and lives for a while and learns whatever it learns, and then the biological host dies, but the soul disengages and goes on to incarnate again.
Okay, well, basically going back to my own observations, in a sense, if you're thinking of souls, in a sense, you're still looking at the idea of separation, that these souls are separate from one another. My observation is basically, I call it heart mind, where everything is in union. There's no separation. So there's another dimension of reality or consciousness that's happening that brings another dimension to the whole thing. Like,
yeah, well, let me just go back here to this picture. Way here, there's a whole set of 6 dimensions that are separate from matter and dark matter, that are linking, that are giving us all of the dimensions we need. And I've always wondered what in the world was resonant here. It could be some really higher, you know, again, higher dimensional things that provide the unity, because that cuts across everything. It couples into both the matter and the dark matter subspaces.
well, once again, the sense that I have is that there's a deeper level of union where things are not separate.
Right.
In a certain sense, that there's a vast intelligence that's already there, that's been there forever. And it's a different understanding of the universe altogether.
Right.
So that's what I'm
and I think the problem we have is that we have difficulties with expressing that. We're not, we have to be more enlightened or raise ourselves up to these higher dimensions to be able to even begin to express these concepts. And we are who we are.
Yeah, but who we are is just different from what we think. That's
right. Right. That's the only reason why I put this slide in here on esoteric cosmology was there was a whole group of people in the early 17th century in Europe who the phrase Rosicrucian, it's rosy cross. So they took the cross and they put a rose on it, which you can see in the middle picture. But they said that there was a union here of everything, and they tried to tie in the Jewish side of the Kabbalah and notions of alchemy and Christian mysticism and Gnosticism and the Hermetian view of things. And so at the end of the day, there was this higher level realm, and they argued that that's what we should focus on. Now, the problem is that there's no, how to say it. This was just a school of people that arose, okay, and it's missing any of the observations that modern astronomy has. It's attempting to unify a lot of spiritual or mystical concepts together, and it by itself it merits study, but it's for example, it doesn't include, when I look at this list here, there's really no discussion of the Tao of the way, or any discussion of Hinduism and Buddhism.
Except that that's where alchemy came from.
Right. So that's where it could be. You're right.
Well, there's another element I'd like to bring in. This is the observation that Ron made. Like the two of us talked about it. He was very excited about the fact. Basically, the way he described it to me, he was watching an electron travel through space, and it would suddenly disappear entirely and then reappear later, moments later, obviously a very short period of time. And his observation was that that electron expanded to the whole universe and came back. And when that happens, there's a little element of information that is gathered together that appears in the electron from that experience or that expansion. So I sort of, now in a way you could say that's how that controls the universe, but the other way of saying it is that that's how the union of the universe occurs. Everything in the universe is expanding back, yeah, and coming back. And so, in other words, there's this is kind of like my understanding of union. Everything understands in that level of reality what's actually happening in the whole universe. So that kind of contributes to my idea of where the level of union actually occurs. It's kind of like once again, it's like a level of awareness. Like Ron had the level of awareness where he could see an electron suddenly disappear and expand to the whole universe and come back.
I talked to him about this, and I interpreted it to be this way, that if you really believe that the motion of the electron it's going to hop from one space compartment to another one, following some physical law that governs its path, then what it's doing is it's in a space compartment, and somehow it's got to get to this totally separate space compartment, might be right next to it. And in order to do that, it expands to be able to sense where it is, and then it picks the correct space compartment to go to according to whatever the underlying law is, and keeps that. So it has a track of the path that it took. And it does this repeatedly again and again. So it's in a space compartment, all of a sudden it disappears and pops up in another space compartment again and again and again. And that's, so you never actually see it moving. Okay, it's just there. And then it's there, and then it's there, and then it's there, and it's going through these expansions all along the way.
And contractions.
Yeah, and contractions.
Oh.
Yeah.
And tie this into
But I'm trying to convey what I got out of talking to Ron, and I could have misinterpreted. We ran out of time, I'm just telling you what I was trying to do to make it consistent, because he was able to see that space was made up of these compartments that made up the foam, the discrete quantum foam that makes up space, and that's where everything resided. You could have an electron in one space compartment, and then it would hop to the next space compartment and so forth. But the hopping process was what you just described. It's the expansion to see what was going on, and then it picked where to go.
Can you tie this together with the double slit experiment?
Well, the double slit experiment, he's sensing there's either one slit or two slits. So the electron's there and it's coming out of its electron gun. And all of a sudden, instead of one slit, there's two slits. So it's again going through this expansion, as Bruce just said, of sending out this wavefront to try and detect where it should go. And because there's two slits there, it realizes it has to behave like a wave and not like a particle. But it knows that instantly. As soon as there are two slits there, it's always scanning. Those expansions are scanning. Where am I going? What rule should I follow?
And it's faster than the speed of light.
Yeah, it has to be faster. You can't have any delays in doing this. If you did, all hell would break loose. So,
but it seems to be through this principle of expansion and contraction.
Yeah.
That's instantaneous.
Yeah.
If you can even call it that.
Yeah. Well, once you go ahead and however long it takes you to swap out the one slit for two slits, that's a long period of time. However, you can't just swap it out. Or the other thing that people did was they put an observer in there, a camera.
Right.
Well, you detect the camera immediately. So if it's a camera, then you know you have to behave like a particle. Okay.
And why it follows that rule, nobody knows.
No, the rule is just built in. I'm not smart enough to know why the rule is there. I'm just saying that's what the rule is. The observations define what the rule is. So here was just as a follow-up on this, the tarot and this chap, Aleister Crowley, who he was a Rosicrucian. You can see here's again a picture of the rosy cross, the cross with a rose on it here. And here is this picture. This to me looked like an Orphic egg here, where he's got this serpent running around here, and here's something that looks egg-like to me. So
well, there's a Calabi-Yau manifold in there.
Yes, there is.
And this was created in, I forget, early 1900s.
Yeah, 1910.
Yeah.
Something like that. That's where this came from.
So it's the card that it's normally, the card that it's patterned after is the world. And those are the four beasts of the apocalypse in the four.
Yeah, there's
corners.
1, 2, 3, 4.
And it's a bull for Taurus, it's an eagle for Scorpio, it's an angel for Aquarius, and a lion for Leo, the four fixed signs.
Mm-hmm.
And that's the periodic table in there. So,
Yeah, trying to show this here. So the only reason we're bringing this up is this is an attempt to try and merge something that's, I'll just say, mystical or spiritual in nature with something that might begin to match what the cosmologists had observed, that the space is spirit in its attenuated form. Matter is crystallized space or spirit. Spirit in manifestation is dual. We see a form that's negative and crystallized and inert, and the positive pole manifests as life, galvanizing the negative form into action. But both forms, life and form, originated in spirit, space, and chaos. And chaos is not a state which existed in the past, and not a state which has existed in the past, and is now entirely disappeared. It's all around us at the present moment. And so it goes with this work.
Read the last paragraph, go back.
Were it not that the old forms, having outlived their usefulness, are constantly being resolved back into that chaos, which is also constantly giving birth to new forms, there wouldn't be any progress. The work of evolution would cease, stagnation would prevent the possibility of advancement.
And then where are those quote marks from? What are you quoting?
It comes out of this Rosicrucian work that quoted what's his face, Aleister Crowley. And here was something totally different out of the Judaism side of things. So they're going back to the period of roughly 10 to 200 AD, and this ends up taking them off into notions that they ended up finding in the Kabbalah, where God contracted part of the infinite light, or the Ein Sof to create the world. And the problem with this is, this appears to be talking about the creation of the universe, but if the universe is really going through a bounce, which bounce is this? It just starts off trying to get the universe going, but will the universe go through bounce after bounce, like the Hindus supposedly claim? And prayer is the entity that releases these sparks of God's light and allows them to reunite with God's essence. So we have the gathering of light and souls through the contemplative performance of religious acts, or prayer, or meditation, and so it goes. So
it's the world of rectification. It's the idea that humans are involved in the recreation or the healing of the universe, which is a really nice concept, I think. That when we embrace our awareness of the unity through contemplation, meditation, prayer, that helps to heal the split, the division, and that process is part of Kabbalah. It's the path of return back up the tree. The creation comes down the tree toward the illusion of differentiation that we have, that we exist in, from the unity to us. But there's a purpose to that, because it's our job to bring that back to the unity by contemplating the multiplicity and the unity within each other. That does something different from just having that original blob of unity.
mm-hmm.
Through the filter of consciousness,
Right.
It repairs something.
Right. So this is an attempt to try and touch on some of these other traditions, and so it goes. So let's get out of this. So the
Enough of that.
the problem that you face with the Western science side of things is they're still gathering data, and the latest telescope, which is the one called the James Webb Space Telescope, it's actually on the backside of the moon in orbit there. So it has the moon in the way, so that there's nothing from the Earth that's going to go disturb it. And it's been there for a year now, gathering all kinds of information that suggests that everything that they talked about for this Big Bang is wrong. And they're doing their best to kind of like hide it. Because here they've invested their whole careers in this Big Bang thing,
And this is why you should believe in science. 'Cause
Yeah,
other things are superstitious, but science, now that's the truth.
Yeah, well, science is a social endeavor, and that's exactly what the problem is. And there's money at
It's a
stake.
dogma. It's just another dogma.
Yeah, and the money is controlled. You know, there's a group of people that control the money, and if they all have their reputations resting on supporting this Big Bang, which has all kinds of, you know, scientific problems to it, you know, they'll continue to support it because they can fund, you know, the people that are doing this stuff.
I mean, they
So-
might as well be high priests in pointy hats, you know?
They are.
Sorry.
They are. I mean, you know,
Nothing against priests in pointy hats. I think in the way they're more honest.
yeah. No, I mean, look, to get the money to go launch this telescope, to go to the backside of the moon, okay, and it's got this gigantic mylar sheet there that is gathering light. So it's gathering far more light than the Hubble telescope. Plus, it's not in orbit around the Earth. The Hubble is in orbit around the Earth, so it's moving. You know, it's 400 miles up, so it's moving all the time. This thing is kind of sitting there on the backside of the moon, you know, not really moving.
Why
it's
did they put here?
because there's no interference, and it turns out that
The gravity just keeps it.
a French mathematician, Joseph Lagrange, in 1790 or so, right in the middle of the French Revolution, when everybody's getting their heads chopped off with a guillotine. So Lagrange wrote a paper called the three-body problem. And so he said, well, what if we have, you know, like the Earth and the moon, okay? And then we have a third body, which is just a very small little fleck, okay? Just very small. Is there any place that we could stick that third body so that it would be in some sense stable? Well, one obvious thing is, suppose I take the Earth and the moon and I look at a line that connects their centers, okay? There ought to be some point on that line where the little speck will get attracted equally to the Earth and to the moon. Okay, and if that's the case, then that's a point where it'll be stable, where it'll sit there forever. So let me just do a search here. I just want to show you what this means. Here we go. Yeah, let's go here. Where did my Zoom go? So Lagrange pointed out this is the very first Lagrange point. Here's like the Earth and here's the moon, okay? And so L1 is the point where the gravity from the Earth and the gravity from the moon equal one another. There's L1. Well, there's actually another one on the same line, which is L2. That's where they put the telescope. Out here, here's the moon, okay? But the Earth, remember, is so massive compared to the moon that it's this point out here on the other side of the moon that has the same tug. So the moon is tugging, but the Earth's tug is equal to it, clear out here. Then that takes us back. Let's follow the line this way. There's a point over here at L3, okay? Now this point, which is again on this line here, is a point where it's attracted equally to the Earth and to the moon, okay? The problem with this point is it's not stable. If I just leave this point a little bit, I'll go flying into the Earth, okay? End of story. And then there's two other points. These are 60 degrees. Here's this line here. There's two others that are at 60 degrees away from the Earth. And people have observed with telescopes that there's asteroids and a lot of rocks that are just floating around here. at these points, okay? So Lagrange discovered all 5 of these points in 1790. Let's see what this thing says.
An excellent location for satellites. But what about the fact that the moon is constantly orbiting the Earth?
Yeah, well, here we go. Yeah, Euler discovered the first 3 that are on that line in 1750. Lagrange did this in 1760. Okay, I was off. Okay, but 1772 is when he published this. So it's people said, well, what possible use is this? Well, here they put a telescope there, so you have no chance of having interference with radiation from the Earth interfering with the what this telescope is seeing when it's looking out here. Of course, it can't look through the moon, so it isn't looking in that direction. It's always looking out away from the Earth.
But what about the fact that the moon is constantly moving?
Well, as the moon moves, this point moves also.
With it, it's always
this is orbiting the Earth. So these points are all going to rotate as the moon rotates. Those points will all rotate with the moon.
It travels with it.
Yep.
Constantly.
Yep.
Exactly.
Yep.
With it.
So, that's, it just shows you, and that was something that Newton missed. And Newton did a lot of astronomy. Who knows? Maybe Newton discovered it and thought it wasn't worth writing down. Anyway,
I'd like to be a little bit radical here. Okay.
Go ahead.
Okay. What's missing is what I call levels of awareness. Like what we need is 50 meditators like Ron, who actually can observe what's out there or in there or whatever, right? Because one of the jokes that my brother and I used to talk about, for example, is that he's never seen, there's no God out there. God is just a concept.
Right.
From a deeper observation awareness point of view, there is no God out there. So we used to joke that when people die, they think there's going to be a God. There isn't one. That was the kind of a standard joke that my brother and I used to have once in a while.
Sure.
So basically, what we need is 50 meditators who have similar abilities to observe with the way Ron did, and kind of figure out some of these things.
Yeah.
Because otherwise, we're lost in concepts.
Well, it's worse than that, Bruce, because Ron is doing the initial stuff, and so if you get more and more people looking at it from different ways, you start to see the depths that are going with this, and you have questions that we haven't even raised here that just start to suggest what's really going on.
That's
so
right.
We're literally just scratching the surface of this, and that's why I just stress that having 100 years of cosmology, just due to these advances in telescopes, after 100 years, they've started to realize that they really don't know what's going on.
Yeah.
And that's because they can only account for 5% of the universe.
Yeah.
They have no idea where the rest of it went.
Yeah. But if you get somebody,
Ron looked and he said, "Here's what's going on."
Yeah. Well, that's what I mean. If you had 50 meditators, they could see the dark space or dark energy. They already know what it is
and compare it.
Awareness. Well, they have awareness of it.
Right.
Yeah.
Right. And that's what's missing from this discussion is first they can't believe that someone could simply meditate to go do this, and then with a paper and pencil, because Ron was a very good artist, he could make very good sketches of these things, and but he didn't have a camera. He didn't have a protractor and a ruler. He didn't have a pencil.
Well, maybe we should talk to more shamans. I think they're more familiar with this. But I just want to say the mystical perspective of God is everything that we're talking about. It's not like a man on a cloud someplace. It's this unity and the logic there, the patterns, the underlying logic and patterns that unify it. It's the fact that there are these ratios. Why are those ratios there? I'm not saying somebody worked it out with a slide rule and a protractor, but it unfolds out of itself in that kind of ordered way. And that order is what you could call God in a mystical.
Yeah, when Ron and I first interacted, I asked him, or he asked me, I can't remember, is there a God there? And he said, well, if you think that there is, I'll tell you it's not, someone on a throne with a beard and a robe and so forth. And I said, yeah, I completely agree with you. I don't think that that's what it is at all. Right. I think it's the pervasive essence of what makes up everything around us is what I would call God.
Right.
And so it goes. So,
or the unity of it with a capital U.
Yeah.
Well, I look at the concept of God as an attempt to explain the nature of consciousness. There's, in terms of normal understanding, nobody can understand the nature of consciousness because they don't have the awareness.
Right.
You have to have the consciousness to understand consciousness.
Yeah.
You have to be able to,
No, there was this guy.
But it seems to be something.
Yeah, Francis Crick, who was with Watson, developed this chemistry for DNA. Okay, and so Crick was a great conceptualizer. He was really world class in terms of what was going on there, and he decided after like 20 years after he'd done DNA, he was going to study consciousness, and he decided to look into the eyes and discuss and study eyes and study neurons, and he concluded after 20 years that he didn't know anything about consciousness, that it was a dead end. It led to a lot of interesting measurements and experiments, but
evolve. They're too complicated, and they're like designed for the purpose of seeing and transmitting that information to the screen of the brain in this way that we it's so complicated we can't even understand.
But I think we have.
But it didn't just
maybe a few
nowhere.
Millennia or whatever to really understand consciousness. I think we have to step up onto a different set of dimensions. It's much deeper.
It's the ultimate miracle.
Well, I mean, the key there is finding a bunch of people who actually can perceive the levels of awareness, the dimensions of
Well, yeah, but they have to be able to explain what they saw. That was the whole thing with working with Ron, was we had a framework that we could talk about and try and put these things into this framework. So the question is this framework sufficient, or do we need a new framework that encompasses this, that it really does the job?
It seems to me like trying to transpose something down so many octaves, like what a dog can hear to what we can hear. If you translate it down, it gets lost in the translation, if that makes any sense.
Yeah.
And the transposition is so much as you're just not going to get all those frequencies. So that bandwidth kind of can't come down here in a way, it seems to me. I don't know. I think it's really
No,
but I think artists and poets and mathematicians really try. And that it's all about relationships, inside and outside, and ratios and it's all
people can sense pieces of this. That's the problem is I wondered what the Buddha or Jesus of Nazareth could really sense, okay? Because I just felt that they were intrinsically already at a different level, out of the box. But did they, I didn't think it was in the Abhidhamma from the Buddha, and we really don't know what Jesus of Nazareth really wrote, what Mary Magdalene wrote down. The church has hidden that. So, somewhere there's a hint at a higher explanation, but we don't have it.
That's right.
So
anyway, we need more Rons.
Yeah, we need to see if Ron's going to come back and visit us.
Yeah, but we need them all together so we get some.
Yeah, right. No, I agree.
I think they should get one from each culture, different time.
I'm sure that these shaman in Africa and in the Amazon, what do they see?
Australia,
but the language, they'll see something, but they don't have any context for it. What framework does it fit into for them to interpret it? It's.
I've heard stories of them looking at our pictures of organisms under microscope, and they'll recognize it. They'll say, "Oh, that's a da-da-da," and we know it as a malaria, organism, and they know it as a XYZ that they have a name for.
But that's what we need the whole framework, the whole vocabulary, and the structure that goes with it,
and some translators that
that by itself is a huge, just having people observe these things, unless we have the framework to put the observations into context to interpret them correctly, we could have nothing to show for it.
Well, if you keep always looking at it through your lens and say, "Oh, well, they're just idiots," you're gonna miss a lot. But like the Hopi, I think they have a completely different way of thinking about time and space, and I think even seeing. I think the way they see it physically, the way their eyes function, is really different because of their consciousness and their way of conceptualizing it.
Yeah, for some of them, Let's call it a night. We'll cook up something for next week out of the syllabus.
What?
We still have one more minute.
Oh, okay.
let's is there anything?
See if you can do a Vulcan mind meld in a dream, Bruce, with Ron, and because you two might be able to communicate because you're twins, that he can kind of recoagulate back into his form.
No, he's incarnated someplace else now.
Right, but apparently you could go back and forth. So if he could recoagulate into being Ron and connect with you as his twin and do a Vulcan mind meld, so your two heads can come together, and then you can come back and translate it to us.
Right.
Yeah, right.
Well, who knows? Maybe he's figured it all out in the time that he's been gone. I wouldn't be surprised.
You can do it.
Yeah. Well, the thing is that I've actually experienced other minds similar to Ron's who have that level of understanding and awareness. And, like the Dalai Lama, my previous teacher, Namja Rinpoche, they had this level of awareness. And I tell you, they live in a whole different reality, totally,
Right.
But they're totally involved in love and compassion and helping others transcend
what we have here. Yeah,
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 suffering,
Yeah.
transcend suffering. Yeah.
yeah.
But they have these dimensions of intuitive understanding of what's out there way better than you and I do. You know?
Mhm.
And it's really obvious when you connect
Yeah.
to them. So
Yeah, that's what we need to think through, is how to articulate that knowledge, and that's not for today. So
no,
we'll call it a night. We will.
we can't do it in less minute now.
No, we're over the
You're
9
over the
o'clock
minute now.
mark.
Yeah, okay.
So that is it for today. Have a good,
Okay,
and we'll see you
okay.
next week.
To
All
be
right, see ya.
continued.
Yep, to be
Thank you.
continued.
Thank you, Bruce.
Okay.
Thank you.